details now because this is something has to do with passing by reference and passing by value, reference values and um, value reference types and value types. Okay, and we will know the difference of passing an integer versus passing an object like this one. Okay, we will talk about shallow cloning and deep cloning. But can you think of a quick solution, like a quick hack for this problem?
Just for each over the items.
For each for the items, but I really don't remember for each with like if you are using for each, what's inside the for each? You will use pop, right?
No, you will just console dot right line and then put the integer in there in
Yeah.
the parentheses.
What I did was just for each var level in stack, and then I just
Mm-hmm.
console right line the level.
And it didn't pop everything.
No, it's
No, it's still
it,
there.
yeah, everything's still there.
Yeah, it looks like that's what, like internally, what's happening when you remove the item. There's another temporary stack being used. So the thing about stacks, like this is the correct way to deal with them. Now, if the language is offering you something else, the thing is internally there are other things happening. For example, you can search for an item in a stack in C sharp, okay? And you will not lose the stack, okay? But what's happening internally is C sharp using other stacks to store the items while looking for what you want. Then when you are done, it will put them back. So
But in this case, you're removing all of the element.
yeah, like I'm trying just to use the absolute, like the absolute idea, okay, or the absolute way of stack. Like this is how I know stacks, right? Like I know that the rules of the stacks. If you want to get something down there, you need what? You need to remove it, right? Now, I'm trying to stay away from, of course, the language like C sharp will offer you things to help you. Of course, like now there is a function to reverse, there's a function to search, okay? And it's one line of code. But now we want to see what's going on internally, okay? Like internally, C sharp is using temporary stacks to save the items and bring them back. So I don't want to use anything that's not the like the core soul of the stack, like the whole functionality of the stack. Okay, so the way stacks work is that if you want to see something down there, you need to pop. Okay, so suppose that there's no for each. Okay, and suppose this is the only way. Okay, like I'm using a language. Suppose I'm using a language that doesn't have for each. Okay, it like it only has while, and this is the only way to work. Okay, now let's forget the things that C sharp provide, because if we are using what C sharp providing, we won't be able to understand what's going on. Okay, so what could be a solution for this one? Well, how would you think?
You just create a variable that's a clone of the stack, and then just pop the clone.
Yeah, so we can, for example, create a deep clone. Okay, now like the problem is you will ask, okay, what is deep cloning? And that's something we need um, to describe in details. Otherwise, it won't make any sense. But what Kevin is suggesting that, okay, what if I created another clone of the stack, another copy, and worked on that one? So now the other copy, whatever happens to it, that won't be an issue because my original one is preserved. Okay, so what if I thought about something like, okay, I'm popping from a stack, okay, but when I am popping from the stack, I'm not throwing them away. What if I inserted them in another stack? Okay, So imagine a stack. Now, what I really hate here is we don't have a whiteboard. So imagine a stack, okay, with those items. Now, when you pop from the stack, you are actually pushing inside what? Inside another stack. Okay? So when you are pushing inside another stack, now you didn't lose any item, okay, but the order is reversed, right? So what was in the top or on the top of the first stack is now in the very bottom of the stack, the new one, right? So after you finish printing or popping or searching, what are you going to do? You are going to pop from the new stack and push back to the old one. And now the old one returned to the original like situation or the original value, and you didn't lose anything. Now, I'm pretty sure this is what's going on inside when you are using like the sort function in C sharp or the search function, okay? But you won't get to see what's going on. So for now, we just want to go with the like absolute primitives, okay? And try to do everything ourselves. Now, a few months from here, you can use whatever ready functions you want. Okay, so by the end of this function, we said we are losing the stack, so we need to think about something different. Okay. Okay. Uh, okay, without losing the items of this stack. Okay, let's try this one. And of course, let's try it without a for each.
Should end.
You're done.
Okay. So I'm reading about for each and stacks here. So looks is something special in C sharp actually. So in C sharp, what will happen? So as we said, the stack internally, there's an array in that stack. So C sharp is able to somehow, let's say, cheat the way stacks work, and it will enumerate over this internal array so it can read it for you and print the items for you. But you can't use this thing, okay? You can use this enumerator to modify the stack. So what they did, they invented this way, okay, of enumerators, so they can access just to read the elements, okay? So there's no actual pop and push happening, okay, unless you want to modify the items. But the problem is, like this course is using C sharp, like what we are studying now, but our intention is to be a generic course for like any stack, anywhere, any list, anywhere. Okay, so we are not concerned about like, oh, okay, C sharp is very strong, then this is how stacks work. Okay, so we are trying to learn all the data structures in their absolute basic way. Okay, so that's why I'm telling you, okay, let's try do it by hand, because tomorrow you may move to a language and you will probably not use C sharp most likely. Okay, and there are no those helping functions, helping methods, okay, to help you work with stuff, and you will need to do them the old-fashioned way. Okay, so please keep this in mind, like why we're not using the capabilities of the language, because this is not a C sharp course, it's mostly an algorithmic course. Okay, so Kevin, let's see, what do you have?
Okay.
You should be able to share now.
Yeah. Can you guys see my screen?
Yeah. So print stack.
Yeah,
So
it's right
you
here.
have a clone stack, okay, and you created a new stack from it. Okay. Okay. Yeah. And like this is pretty smart. So what Kevin did is he created a new stack totally, okay, and he passed the items of the stack inside the constructor of the stack. Like look at line 53. So the constructor of the stack can take a collection actually. So you can send a list. So when you are defining a stack, you can send a list to the stack, and the stack will take all the items from the list. Okay, and you can also send another stack. Okay, but notice that he's using the new keyword. Okay, when we will talk about reference times, we will say that when you are creating a new one, it will be separate from the old object. Did you verify that it's working?
Yeah, I ran it.
Yeah. Did you like print 2 times? I see you are printing 1 time.
At the, I can do it again, but at the end, I just you see my last line.
Oh,
It'll
yeah. There's
verify
yeah,
then
yeah.
the stack count. Do you want me to run it twice?
Yeah. Let's run to see it. Okay, but it's better if we did this count like outside, like let's keep our function focused on the purpose of why we created the function, which
Okay.
is
It does. It runs fine both times.
yeah. Well, I'm not able to see anything. I'm not sure
Oh,
why.
I'm not sharing my. I'm just sharing my. Hold on.
Visual Studio.
Yeah, I can reshare. Do you see now on here?
Mm-hmm. Yep. Yeah,
I'll
it's
just run it
totally
again.
fine. Okay. So Kevin used like the constructor of the stack to create another stack. Okay. Now, thank you very much, Kevin. What if I don't even have this this luxury of creating a stack out of a collection? So see this stack, okay? So suppose I have let's suppose I have something like list integer. Okay.
Can you share your screen, please?
Ah, sorry. Yeah. Okay. Okay. Suppose I have this list. Okay. Okay. And you can create a stack. Okay. st, let's call it st from list equals new stack integer. And in the constructor of the stack, you can send this list. So now this stack will be created from this list, and the same items will be in the stack. And that's what Kevin did. Okay, because the stack can take any enumerable collection. Okay, any collection, the stack can take it and push it in its initial values. Okay, what if I don't have this option? What if the only way to create another stack is to push in the new stack?
So you need to use a for loop and create manually the another one.
Yeah, well, let's keep using while.
Convert to array.
Yeah. Okay. So what if we said something similar? Write a function to search for an item in a stack using another stack. Okay. So printing is similar to searching. Okay. So the problem with C# that is extremely strong. Like you can do lots of things with C#. Like as Kevin did, as you guys did with for each. I'm trying to assume that I have nothing but push and pull. Just push and pull. How do I keep my original stack without losing the items of it? Okay, using another one.
Using I mean, you want to use that we use primitive data, right? The structure. So for keep the original one, we need to use tree stack because we need to use one, the original one. We need to put the first element and push in the second element. So when we finish the loop with the first one, the second stack will be have the same value, but in the descending way.
Yeah.
But if you want to put back again, like the first,
yeah,
stack,
but you have the original stack. Put them back in the original stack.
Yeah.
Right. Like why create a third one when you have the original stack ready and empty?
It just push back to the original one.
remember that when you push back, okay, you can do that.
Okay, so like imagine you are doing the dishes. Okay, like you have 10 plates and you want a plate from the middle. What would you do? Are you going to break all the dishes one by one?
No, you can't do it with two.
Okay, so what we'll do, you will remove
One by
the
one.
first dish, second dish, until you reach what you want. Okay, you took that one. Now what you do? Okay, now you should do is take the plate, put them back over and over. Okay, and that's it.
Okay, let me do it.
Okay, let's do the exact same thing with code. Okay, now this is the only way for many languages. Many languages, this is the only way to work. There's no other way to do it. Now C# is extremely strong. That's nice. Okay, but tomorrow maybe I'm working with a totally different one. I don't want you to get used to the strong things that you can find in C#. Okay, because what if you move to a weaker language tomorrow? Like, okay, most companies here in Winnipeg, they don't use C Sharp. Okay, so we can't get addicted to whatever C Sharp is giving us. And okay, I can only do things in C Sharp. I can't think outside of the C Sharp scope.
Mohammed,
Yeah.
do you just want the function to return a Boolean, like true or false if it was found? Or what do you want us to return?
Uh, yeah, maybe. Yeah, a Boolean would be fine because there's no point of returning the item. You already know what you're searching for.
Yeah,
Right.
okay, thanks.
So true or false would be like a little bit make more sense.
I'm done.
Okay. So let's see what Sule has. Okay, find item. So the temp stack. Okay, so first, Sule in line 59, he is iterating through the original stack. Okay. Now, every time he's looking at the top item, because we assume that this is the only item we can see. Okay. And if this is the item, then I will finish this while. Otherwise, what should I do? I will take from the original stack and put in what? In a new stack. Okay, why do I have to do this? Because if I didn't put them in another stack, I will lose them, right? So this new stack is just to save what I'm removing. Okay, like, hey, you like stay here until I finish searching. Okay, and everything I am saving in this temporary stack. Okay, now by the end of this while, of course, here you forgot to have like a Boolean thing. Like, how do you know if you found it or not? Like, this function is not returning anything. Like the idea is correct, but just have after you define the stack, just have a result Boolean. Yeah, yeah. The break is still good because you don't want to keep searching after you find it. Okay, you don't. Or instead of the break, you can say while st.count bigger than 0 and what? And st.peak not equals number. But you will write it 2 times. Uh, okay. Yeah, you can keep this one. Yeah, it's fine. Like the way you did it is fine. I'm just suggesting like inside the while condition, you can put the condition of not finding, but that's fine. Okay, break, and before the break, the result will be true, right? Okay, Boolean result equals false. Okay, or found, you can call it whatever you want. Okay, then result equals true here. And where should you return result? Like either true or false, doesn't matter. I will return the result. Okay, but before returning the result, see what Sulay did. So before returning the result, okay, let's go to line 71. Okay, so in line 71, now Sulay finished searching, right? So he will go to that temporary stack where he saved the items, okay, and will take them back to the original one. So now the original one returned to the first shape and it wasn't changed, okay? And this is the only way to do it in many languages where they don't offer you nothing but push and pop, okay? That's all what they offer you, okay? They don't offer you those fancy enumerators or fancy functions or whatever, okay? And this is the way of dealing with stacks in the absolute like primitive way, okay? And if you went to a company that, and for example, especially those big companies, and they asked you a problem with stacks, this is the only solution they accept, okay? You can't tell them, okay, I can use for each, okay? You can't tell them I will need to use anything special from the language I know, okay? You need to use it in the absolute basics. Okay, thank you very much, Sri. So let's write this down and then we can go to a break. So static Boolean find item in stack. Okay, takes a stack of integer. Okay. Okay, let's call this one found equals false. Okay, and I need a temporary stack, okay, where I can save my items so I don't use them. Okay, so can say while what? While I still have items, while st.count is bigger than 0, okay, let's try to do something like, and for example, let's try to do it this way. So while I'm still having items and while the peak is not equal to what? Is not equal to
The target number we are
the
trying to
target.
find.
Yeah, so I need to pass the target number, right?
Yeah.
And number. Okay, and not equals to number. Okay, let's think about this one. Okay, so while I still have item and while I didn't see this thing yet, what should I do? I need to, okay, stay away from here. I need to look. Okay, so I need to take from, so temp dot push. What should I push in the temp? Whatever I pop from the original, right? Okay, I will keep doing that. Now, by the end of this while, I have one of two possibilities, right? So the possibility here is I either finished the stack and didn't find anything, or I found that the peak equals the number. Okay, so can I say something like this? If st.count is bigger than 0, then found equals true. Okay, so if I finish this while I still have items, what does that mean? Like if this while finished and my original stack still has items, at least one, what does that mean?
We
Like,
found now.
Didn't
Found
go
it.
into that loop.
that means this small condition is the condition that broke the while, right? That means I found the item. Okay, do you think this is correct? Okay, so like it's just a way to avoid the break. Okay,
What if the number is the bottom of the stack, though?
yeah, if the number is the bottom of the stack, then
Then there would be
this
zero.
one will pop the number before the last one, and while it will look at the last number, and it will see that it is the number I want, and it will not go into the while, so I will not pop the last number.
Oh, okay.
Okay, because if I saw that, oh, it's like, imagine you are looking at the stack of the dishes and you found, oh, the last dish is the dish I want. Are you going to pop it to the temp?
Right. Okay.
No, you will not remove it to the temp because, oh, I found it. Okay, and now you can do whatever you want with it. Okay, now found equals true. So what should I do now so I don't lose my original stack that was sent to the function? While what? While temp.count equal bigger than 0. So I need now to, okay, those guys that I saved for later, I need to put them back in my original stack. Okay, so st.push whatever in that temp. And of course the temp will be totally lost, but I don't care about it. It is a temp. I need to return found. Okay, so you will notice that working with stacks is not very straightforward. Like everything you need to see, you need to remove anything above it. Okay, that's why it's a little bit of like, unless you are pretty sure, you always need the top item before the item beneath it. Okay, then using a stack is not the correct option. But in many cases, using a stack like makes sense because you always need what you pushed the last. Okay, now if you understood this and what's going on here, then you understood the basic functionality of stacks. Okay, and you went like to the absolute basics and absolute primitive ways to work with stacks. You didn't use anything ready, and this code will work in any language. Okay, any language that supports stack, this code will work with, and you don't need to worry about is there a special function, is there not. Okay, now let's take a 15 minutes break, and we will come back to talk about something similar to stack. Yeah.
Sorry, Mohammed. I just got a little question for
Sure.
so there's no public right now for the function at the
Uh,
beginning of static. So is that
Yeah.
okay?
Well, if they are in the same file, you don't need public.
Oh, okay.
Yeah. We will study in the detail this in details: private, public, protected. Okay, but
Okay.
if you are in the same file, then you don't need. And of course, same file and same class.
Oh, okay. Okay.
Okay.
Thank you.
Yeah, you're welcome. Okay, let's go for a quick break and then we'll come back to continue with cues. Or I found its pair, right? But
Mohammed,
yeah,
so are we trying to just verify if it's balanced parentheses or if it's correct?
what do you mean by correct? Yeah, I just want to know if it's balanced in terms of parentheses.
Okay, so then we just have to compare number of opening to closing bracket.
Yeah, but we said number isn't enough. Like, look at this statement. The number is
Right.
the same, but it's still
But it has to follow an open close sequence then.
exactly. So
Okay.
they need to be the same number eventually. Okay, but what do I care about is like as long as you see opening ones, that's fine, right? Because maybe they are closed at the end. Okay, so as long as you are seeing, but once you see a closing one, what should you do here? Once you see a closing parenthesis, what should you do? You should look at your package of opening parentheses. Like, do I have an opening parenthesis for this one? Yeah, I do. Okay, that's fine. So you need to store them in what? Store them in a stack. Store all those opened ones in what? In a stack.
Stack.
Every time you encounter a closing one, okay, remove one from the stack. That's fine. Okay. Now, if you encountered a closing one and your stack of opened ones is empty, what does that mean?
False.
Okay, like I just found a closing one and my stack, okay, my stash of closed of opened ones is empty. So who is this closing for? Like what are you closing? Like I don't have any opening parentheses for you. What are you closing? That means this is false. It's not balanced. Now, it's very important to use the stack when you have other types of like balanced things like brackets or codes or okay. So this, if you are only talking about one type of parentheses, you don't need a stack. You can use a list. Okay, but if you are talking about different types, that's when stack is like the most preferred options. Okay, so let's try to do this. So the idea is whenever I encounter an opening parenthesis, that's fine. I will push it in my stack. Okay, I have a stash of opening ones. Okay, whenever I encounter a closed one, I will see, okay, do I still have opened ones so I can pair them? Okay, now if at any point I found a closed one without seeing an open one, or without having an open one in my stack, what does that mean? If you found a closed one without having any one to pair with, that means
It's
it's
false.
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 Okay, what is the other case of false? Like this is the first case of being false. What is the next case?
If we have more opening than the closing.
Yeah, and how do you know, like what if there's an closing somewhere? How do you know that there's no more letters?
At the end, we should compare.
Yeah, that's it. Don't
Count.
continue. Don't continue. At the end. You okay? At the end of the string. Okay, that's the correct answer. Okay, I'm not sure what you were saying, but this is the totally correct. So if I finished the string, okay, I finished, and my stack of open parentheses still has like more than one, okay, or one, that means, oh, I have something like this. Okay, so I have lots of opened and I finished the string, but I didn't pair those. I didn't remove them from my stack. Okay, so you have two cases of being false. Either finding a closed one without having any open ones, or finishing the statement, finishing the string while you still have one of those. So once you find a closed one, you should get rid of one of the opened one. Just get rid of it, which means pop it. Okay, throw it away. I no longer need it. Okay, let's try to write this in code. Now, I'm not pretty sure if everyone understood what the solution is. Do you want me to repeat, or do you want, like, if you understood, start writing the code. Otherwise, please let me know. I can explain it. Okay, I can explain the algorithm as is. And this is what happens internally, actually. They use a stack and they compare, okay? And then they will tell you right away, oh, there's an extra one, either closed or open.
So the input for this function would be string.
Yeah, just a string that has some parentheses, okay? And of course, do you
Would-
care about the letters? Do you need to push those letters to the stack? Regular letters?
What into the comparing step? No.
No, you only
Just to
need a
remove.
stack for the parentheses themselves.
Yeah.
Okay, when
Okay,
you
and
see
if-
a regular character, just pass it.
Okay. And one more. If there's no parentheses, still true? Or
Yep.
no parentheses. Okay.
Exactly. Yeah. No parentheses means true for sure.
Yeah.
Or maybe no letters at all. That's also true. About 7 years ago, I did an interview with Booking.com. Anyone knows this website? So of course, I was in another country and was desperate to travel anywhere. So they are in the Netherlands, and that was the first question they asked me. I did very well, but I did horrible in the next one, and then the next one was 2D arrays, and it was very hard. I still barely
Speaking
know.
of 2D arrays, the last question of yours from yesterday, did people go through it? I couldn't.
Really? Well, the answer is online. So,
Is it?
uh, what people? Do you mean people, other people here, or like
yeah,
in
other
the
people
class?
here. Like yeah.
Yeah. Well, as I said yesterday, if you didn't know the answer, like there are lots of answers with their explanations online. You can. The idea is just to try to think about it, but the solution itself is not a secret. You can find literally thousands of attempts. Okay, or maybe you can read the idea, just read the idea and try to code it.
Okay.
So
Okay.
like don't read the code itself, just take a hint or something and okay, continue from like the hint I gave you about stacks now.
Okay.
Okay, but like that was, and it was for a senior programmer, so this is not an easy thing. Like if you understood this question, if you can code it, this is an achievement. Now, after you finish, try to see if your code will work if you have other types of closed and open scopes, like those brackets, for example. Generally, it's if your code is correct, it will require very minimum change to make it work for any scopes, regardless of what type they are.
We need to use the quit, or we can use get element add.
No, this one is not queues. This one is tags. So you need to push and pop.
Oh, I got it.
Yeah, this one is definitely stacks. Yeah, the word any actually is, there are so many types. Let's say we have two. Okay. Let me help you just by writing comments on what should happen. So static.
I'm done.
You're done? Yeah,
Yeah.
great. Let me just write a few comments here and then we will see your solution. And this takes a string. Okay, so okay, so here I'm talking about any scope, not only. If the character actually. Okay, so this is the algorithm we are trying to write here. Okay, so scan the string character by character. Now, if this character is an opening scope, push it to the stack. Now, if the character is a closing scope, of course you need to define them like this or this or this. There's no way but to hard code them or maybe put them in a list themselves. Now, if it's an closing scope, we need to check the previous stack and pop the first item. Okay. Check that it matches the closing scope. Okay, so this code will work on any type of scopes, not only those parentheses. So when I pop a bracket, or when I see, like at this point, if I saw a closing bracket, then what should be the top of the stack? Like if you saw a closing bracket, then the top of the stack should be what?
An opening one, if it's
An opening bracket from the same type. If it's from the another type, this won't work. Okay, you need to retain false. So here, this code is more complicated than the one we talked about because it deals with all types of scopes. If the character is okay, now it's more clear. Okay, so every time you see a closing scope, anytime, you need to check this tag. The top item should match this closing scope. Otherwise, if there are no items, if it doesn't match, then this is false. And we need to keep doing this until we reach the end of the string. Now, if we reach the end of the string, if there are any items left in this tag, that means we have more opening scopes. Okay, that means we need to return false. Otherwise, if I reach the end of the string and the stack is empty, that means this is a balanced one. Okay, now we have a few minutes. Let's see the solution of Sulaim. Sulaim, can you share your solution?
Okay.
Okay. Why are you pushing one? So
Because
so
I just push when I found the open ones. I just push one.
yeah.
and
So this works. If you are pushing one, this will work only on this type of parentheses.
oh,
Otherwise, why not push the parentheses itself? Like make a stack of characters. So what Sule is doing here, every time he sees open one, he's pushing it to the stack. Now, if he saw a closed one, what should you do? Let's go down. So if he sees a closed one, okay, he's checking the stack. If there's nothing in the stack, no opening ones, that means it's false. Otherwise, he will remove one of those. This is a perfect solution, Sule, but it works only of this type of parentheses.
yeah.
Okay? Now let's write another version. Keep this one.
Mhm.
Okay, keep this one, and let's write another version that works on like 3 or 4 types of, like, or maybe all of them. Okay,
Yeah,
like let's cover more.
Another thing is in the line 83.
83.
83. Yeah, if you don't have, if your first element is not this parenthesis, the open parenthesis, you need to finish your program because it's no.
Yeah, well, if it's not, like you mean if it's a closing parenthesis or anyone?
Yeah, if it's closing parenthesis.
Yeah, if it's closing parenthesis, it will
Break
go to the
and
if.
finish. Yeah.
Yeah, well, it's just another if, so you don't really need to finish. Like here now, you will break. Yeah, you will add like an extra if, but like
And,
if it's
and at the end.
yeah, but if it's a closing one, you will go to the line 87. Where's line 87? Like imagine the first letter is a closing one. Then
Yeah.
you will go to the 87, right?
Yeah.
You will check the
If
you will check the stack, which is still 0, and you will return what?
should 91 be true?
No, it
False.
should be false because
Okay.
he's like Sule is saying, if I found a closed one, but my stack of opened ones is empty, then what are you closing here,
Oh, I see. Yeah, okay.
right? So I really think it's correct. So even if the first letter, like the very first letter is closing parentheses, it will go to the if in line 87.
Yeah.
It will check the stack. It will see that the stack is still empty. Although it's still empty, I'm closing, which is against the rules, and it will return false. Okay, Willie. So Willie just wants to exit. Like Willie is this type of, he cares about those nanoseconds in programming. Okay, so you will save maybe a few nanoseconds here, which is not really a big deal, but you will make your code more complicated. Okay, you don't need to care about the case where it's like I just want to go quickly if it will be served in the if itself. Like the second if will serve you like fully well. Okay, so that's a perfect code, but it works only for what? For this kind of print.
Yeah.
Now let's write another one, or like after the class. Now let's go to a break. Try to write another one that uses more types of parentheses. Okay? But congratulations. If you are interviewing at booking.com, you will be able to pass the first half. You will fail in the next half, but that's fine. But at least you will pass the first one.
Yeah, thank you.
No, you won't fail. I'm just joking. Like, hopefully you can do better than me. But like my mistake was I just went without preparation. I like was depending on what I know from university few years ago, and I was really expecting questions like memory management, questions like objects, classes. I didn't expect that this is what they do in big companies, but apparently that's what they do, and they're still doing until now. So if you ever want to interview for those companies, you need to spend a month or two just solving algorithms from this kind, like this exact type. Okay. After the break, we will take a look at the assignment. Okay, we will explain it, and maybe you can start working on it so you can see if you have any question. Okay, I don't think we have any questions left, but we'll see. Okay, we'll see after the break. Okay, see you soon. Bye. Okay. So I have a stack. Okay, it has a stack of integers. It has some numbers. I want to remove only the minimum item. Okay. So I want to find it and remove it, whatever the minimum item is. Okay, and then I want to return the stack, okay, with all the items except the minimum one. So it will be less than less by one item. Now, if you found more than one copy of the minimum item, just remove one of them. Okay. Or you can remove all the copies of the minimum item, whatever you prefer. Okay. So if we are talking about this stack, okay, so I will return this stack without the 12. Okay, if I have another 12, then it's fine. You can remove all the 12s. Okay, all the minimum items. So what should I do here? And of course, it's a stack, not a queue. How do you solve this problem if you have a real stack of blocks in front of you? Of course, assuming that you don't know what is the min yet. Okay, so you are not using a function like find the minimum. Okay, and you want to do it in the fastest way possible. So what if I did the following? What if I have the stack, okay? What if I moved all the items to a temporary stack, and while I'm moving them, I will keep track of what is the minimum item. Okay, so I will be moving all of them while I am tracking, okay, what is the minimum item so far. Now, after I move all of them to the temporary stack, okay, now I have all of them in another stack and I know what is the minimum item, right? So what should I do now with this temporary stack? I need to put everything back in the original stack except of what? Except of the minimum item. Okay, and now my original stack has all the items except the min one, and I got rid of it completely. It will stay in the temporary stack, but that's not important. Like, I don't care what's in there. I care only about the one that I will return. Okay, so let's write this code. Let's try to implement it in C#.
I have a question. Do we have to move the stacks? Can we go through them with for each and use like one temporary number variable for int or something? And if it's smaller, put it in there and then later return that int variable?
You can't take it out if it's like, suppose you are going with a for each.
Yeah.
And you found the minimum item. How are you going to remove it? You can't remove it because there are stuff above this item. So at some point you will need that extra stack to remove. Okay, remove everything.
Okay.
And what if I want to remove all the minimum item? Like maybe there are more than one copy and I want to remove all of them.
Okay. Yeah.
So if I want to remove all of them, your code won't work because maybe there are more than one copy. Okay, so let's try to write this code and like implement it step by step. Uh, are we talking about mathematical expression? No, we are not going this far. Um, I'm not sure if you mean the math here. No, we are just caring about parentheses. That's all.
Orange. I was doing another thing. Oh,
Yeah, if you are talking
I
about
finished.
validating like a math string, that would be pretty hard to do. Like that's not easy.
Yeah,
because-
that's hard and that's so.
yeah, it can be done and it can be done with stacks, but we are talking about math. You are talking about how to calculate stuff inside
Yeah, that's a
scope
problem.
and powers maybe. Yeah, no, we only care about parentheses regardless of what is
Okay.
the content. Okay.
Okay, I did it. Yeah, few
Okay.
minutes ago. So you need to. The another one is find the.
We want to remove the minimum element in a stack.
In
So
one
I have a
loop.
stack.
I can
Sorry.
use one loop or two.
Do well.
Or
You
I
can
can
do it
choose.
in. You can do it in one. I don't think it can be done in one
I'm done.
because you need to move all over the stack. Then, so you can do it in two, but they are outside each other. Okay, they are not like inside each other. So it's still on.
In one.
No, you can't. Well, if you can do it in one, that's fine. Yeah, but if you want to remove all the minimum elements, then this won't be done. Like you can do it with one for or one loop.
I'm done.
So I explained the main idea. I'm not sure if you were listening. So we will use a temporary stack and we will move items there while keeping track of the minimum item. Then we will put everything back in the original stack except of the minimum items.
Yeah, but that's my question because if we do that, we need to have two loop.
Yeah, we can have two loops, but they are not inside each other.
Okay, I got it.
Okay, they are outside each other. Okay. Okay, any solution? Anyone is done?
Yeah.
Okay, so Millie and Slay. Okay, we'll see Millie's answer. Let me allow you to share. Okay, you can share now. Okay, so remove minimum item. It should return. Why are you returning an integer?
I thought that I should return just that minimum item.
Yeah,
But
well,
if-
either you don't need to return anything or return the stack
Okay.
itself.
Okay.
So you can keep it void or you can retain the new stack.
Okay.
Yeah, but stack is, yeah,
yeah.
you need to change this time.
Yep.
Okay. So, why do you have a problem in twin st.peak? What's the problem here? Yeah, let's go to the first issue. So line 47. Why there is
I don't know. I didn't hear that.
okay, let's make it void. Okay, just instead of integer, make it void. Okay, now we have the stack, the temporary stack, and min is the first item. Okay, that's nice. then while the stack has items, okay, while there are still items, every time we will check the peak. So you don't need the peak because you are doing a pop anytime.
Okay,
Anyway.
I can use just pop every
Yeah.
time instead of
So you
peak.
don't need to do peak then pop because it's like just pop will return the item.
Okay.
Okay. If yeah, but now the code.
Yeah, that's
Yeah. Yeah, like you don't need the peak at all. Okay. So okay, keep it this way. So if the peak is smaller than min, then the min is the peak. Okay. Then I will take it out and push in the so the pushing will be done regardless of the if and else. So right, so the push
Yeah.
is in the if and the else, so it doesn't need to be in the if else, right?
yeah.
So
It doesn't be separate.
you don't need the
Yeah.
else. Yeah, you can get rid of the whole else, the first else, okay, because it's not doing anything special. Yeah. Okay, and remove this one. Okay, and remove the. Okay, now what you're doing here, you are popping anyway, right? But if you found something smaller than min, you will replace the min. Okay,
Yep.
but you will pop anyway. Okay, now in the next while this is the second loop. We will take all the items from the temporary back to the original, except for what?
Except the minimum item.
The main item. Okay, so if the main, if the peak is min, you are just popping and throwing it away. Okay, that's good. Else you are taking it out and putting it in the original. So see, in line 64, okay, what Millie is doing here in line 64 is she is popping and throwing away. She is not inserting this item back to the original. Why? Because it is the minimum item. Okay, and this code, the nice thing about this code, it will remove all the minimum items, not only the first one or the last one. Okay. Otherwise, if this item is not the minimum one, then I need to put it back in the original stack, right? And this is the job of the else. Okay, so now the code is totally fine, but you don't need the peak. You can use the pop right away. Right? So
in each statement.
yeah, so what you can do, you can even remove the like you can do the pop first, okay, and and you can save the pop in a variable, but keep it this way. I will write the solution the other one, okay? But this solution is totally fine. Okay, so is the idea, guys, is the idea clear here what Mil is doing? And Sule, is that what you did?
Yeah.
Yeah, so it's the same idea too, okay? Except like just be careful when you are doing if else, like if you can simplify it, okay, like we didn't need that else.
Yeah, I didn't.
Okay.
I didn't.
Yeah, but that's totally fine. Okay, yeah, thank you very much. Okay, let me share now. Okay, so let's write the code of static. Let's make it void. Remove min items. Okay, this one takes a stack of integers. So you don't need to return the stack because you are modifying the same stack anyway. So if you returned it or you didn't, it's the same result eventually. Unless you don't want to modify the original stack, then that's a different story. Okay, so st. Okay, so I need a temporary stack. Okay. So what should I do now? I need to keep taking things from the original to the temp while keeping track of the minimum. So int min item, the minimum item is the, let's say, the first item. Okay, so I can say st.peak. Okay, I don't want to remove it yet because when I will remove it, I need to push it to the temporary one. Okay, so what should I do here? Okay, while there are items in the ST, the original one, okay, now var x equals st dot pop. Okay, now I will push this x. Okay, anyway, I need to push it. So temp dot push this x. Okay, now something else I need to know, I need to keep tracking of my minimum. So if this x is smaller than the minimum, then the minimum is what? The new minimum is what? Is x, because x is smaller than my previous minimum. Okay, it's the same thing we did with lists, with dictionaries, with everything. Okay, now by the end of this while, I will have everything moved to the temporary stack, and now I know what is the minimum item. So what should I do? Sorry, while the temp is not empty this time. Okay, now I need to take them one by one. So, okay, so var x equals temp dot pop. Okay, now I have two cases. I took the x from the temp. Now, if it's not equal to the minimum, then what should I do? I need to put it back in what? The original one. If this x is bigger than the minimum, okay, then what should I do? And that's it. So that's like without having any redundant peaks or else's or anything. Okay. So otherwise, what happens here? Nothing. Like I just popped it. It will go away. Okay. And in the next while, I will pop the next one. Okay. And that's it. Any question about this?
The first time when you just used peak for initial min, you said you don't want it to be popped.
You mean, yeah,
The
because I
line
just want,
101.
yeah, otherwise you need to make a pop and a push. Like, okay, like you need to choose what is the initial min. So initial min,
Right.
let's say, is the first item. Okay. If you want
Yeah.
to pop it, then what should you do? You need to pop it and put it back in the temp, right? Otherwise, it's lost. The first item is lost. If you did a pop here,
Okay. Yeah.
okay, if you did a pop, you know the min, but it's lost. It's gone. Okay, so we don't want to lose it until we start pushing to the what? To the temp. Otherwise, we will lose the first item. Okay. Okay, that's for stacks. Okay, and I really hope that you redo those questions and you can search for extra questions. There are hundreds of algorithms and problems that use stacks, and lots of them are interesting. Lots of them are really hard, but they are really like entertaining to work with. And once you start working with them, understanding them, it will really feel really like very rewarding, and it will really feel nice. Like, oh, I really appreciate how many problems can be solved easily with stacks. Okay, so I will send you the assignment, but let's talk about it first, because I won't have time tomorrow to talk. Okay, what's this? So it's better now. Okay. So this is our assignment. It's 2 questions. Okay. And I will give you enough time. So it should be next Monday or next Tuesday. It depends on if I get into the system and I can start working with LMS. But anyways, okay. So question 1, we have a vending machine. Okay. So imagine like a vending machine, like those Coke machines where you buy snacks or Coke or anything. Okay. We don't want to talk about the purchase operations. We are not doing purchase transaction. We will just talk about and solve the problem of returning the change. So suppose that you are buying something that costs $12. Okay. So you will insert $15, right? Or like suppose that you don't have exactly 12. You only have a 10 and a 5. You inserted 10 and 5. So what the machine should do now?
Return $3.
Return $3. And those, like, do we have $3 here in Canada? We don't have $3. We have 1 and 2 and 5. So the machine should know, okay, the exact number of change, okay, and return it to you. Like it will know, oh, I need to return 1 piece of $2, toonie, and 1 piece of $1, a loonie. Okay. And of course, it should return the minimum amount of coins. Okay. So imagine that the machine should return $9 for you. So what should the machine return?
$5.
$5 and
$2 too.
$2 and $2. Okay. Of course, the machine shouldn't return 10 single dollar or 10 loonies or $9. Each one is a coin. Like eventually you will have a bag full of coins. Okay. It should return the minimum amount of like currency, either paper or coins or whatever. Okay. So this is our problem here. So my problem is I will write a function, okay, that buys from a machine. Okay. So I will say the function will take the price of the thing you are buying, the amount of money you entered, and it will return what? It will return an array or list of what is the exchange or the change that you need to receive back. So, for example, the user will enter 25. Okay, so this is the input of the function. And also from the input, the user will say, okay, I'm buying a $2 item. Okay, so this is like, imagine we have a 25 bill or the user just entered 25 and he wants to buy $2 item. So what is the return from the machine now? How much money the machine should return?
$23.
23. Okay, so how do you represent 23 in terms of change? But you need to return the minimum amount possible. So you will return a piece of $20 and a piece of $2 and a piece of $1. And those are the sum is 23. Okay, and those are the coins that you have. Like you can insert anything, any amount of money to the machine, but those are the coins that the machine has. The machine has a number of loonies, a number of toonies, a number of $5 bill, a numbers of $10 bill, and $20 bill. That's what the machine has. But you as a user, you can insert whatever you want. Okay. And this is the main condition. Okay. Now, that's the first step. Now, the next step, you should keep tracking of how much of each coin the machine has. So the machine, maybe it's out of $2 coins, or maybe the machine is out of those $5. So you need to not return something that's not in the machine. So when in your main function, okay, you need to say, okay, machine is this data structure, maybe a dictionary, maybe a list, and you need to say that from $1 I have 10 pieces in the machine. For toonies I have 5 pieces, so I have 5 toonies. So when you are returning, maybe the user needs 6 toonies, okay, 6 $2, but the machine has only 5, so you should only return 5, and instead of this $2, what should you return? Like 2 loonies, 2 $1. Okay, like it's just what if the machine is out of certain currency, you need to return something else. Next one. Okay, so if the machine is out of 5 of all 5s, what should you return instead of a 5? 2 2 and 1, 2 2s and a 1. So this is a very interesting problem to work with. So write a function that takes a machine. Okay, I will tell you, it's a dictionary. Okay, so how do you represent the machine? By a dictionary. You will say from $1, this is the key, I have 6 pieces. Okay, 6 coins. From $2, I have 10 coins. That's you need to send to the function. And you need to send to the function what is the price of the thing the user is buying and how much money the user entered. What is the return thing from this function? What should you return?
Dictionary.
It's also a dictionary. You should return, okay, from $20, we will return 1 piece. From $2, we will return also 1 piece. Okay, and that's so this function will take a dictionary with other things and will return a dictionary that represents the exact correct amount of money the user will get back. And this is actually what happens in those machines. Okay, this is exactly the algorithm. Like you will never see a machine returning like 12 loonies for you. Okay, it will try to retain the minimum amount, and unless there is no, like it's out of stock of this current bill. So maybe when you will send a dictionary of a machine, you will say like, I have 5 loonies, 6 toonies, but 0 5s. Okay, so if there are 0 5s, then you shouldn't return a 5. Okay, it needs a little bit of thinking, but it's nothing but whiles and ifs and maybe fors. Okay, but it really needs you to think in a very step by step. Watch yourself, what you're doing, what you're returning. Okay, but there's no like crazy idea behind this question. Okay, is it clear what we want here? Not like now, maybe you don't know the answer yet, that's fine, but you need to know what is the question. Okay, this question number 1. Now, question number 2. So we want to write a simple compression algorithm. So I have a long text, and we noticed that in many times we have the same character repeated. Okay, so we want to compress the string. How? Okay, we will say if we find or if we saw a letter and the next letter is different, then we copy the letter the same. Okay, if we saw 2 letters like you and you, then something else, okay, then we copy both of them as is. Now, if we saw more than 2, like I saw here 4 Fs like behind each other, like F, 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 F. Okay, so what should I write in the compressed version? I should write first what is the letter and then how many times it showed up. Okay, so F4 means there are 4 Fs here. Okay, what about the P? So I have P, P, P. It should be replaced by P and 3. So notice how this is the original version. This is the compressed. The compressed version is smaller. Now compression is like totally use this if you can't return the original string back. Okay. So we need first to write a function to compress a string. So this function is very easy in terms of input output. It takes a string, it returns a string. Okay. So it takes a string like this, it returns a compressed string like this. Okay. Of course, here we are assuming the original string is only letters. If there are numbers in the original string, we don't want to handle this case. Okay, that would make it much more complicated. And they are only upper letter cases. Okay, just to make it easier. Okay. And the next one is I want to take a compressed string and return the original one from a compressed string. So you will take a string that has letters and numbers, and you should return the original one back. This is how compression works, right? Like you compress a file, then you decompress the file. And actually, this algorithm was used in the early days of compression, that it was used, and it will save space. Okay, like notice how it shrinks. So we want to write this algorithm. So here we have two functions. One compresses, one decompresses. Okay, now you don't need to find the optimum solution. Like if your code makes sense, if the idea is 90% correct, but there is a bug somehow, okay, don't be stressed out. That won't make you fail. Now you will fail in only one condition, is that if I didn't see that you made any effort. Like if you send me a file that has few lines of random whiles and ifs thinking this can work, okay? And it happened the last time, and we had all the struggle with the student, and I will become better, and it was a very long story, okay? And honestly, like if you don't want to care from the first course, then like what are you going to do in the harder ones? Like this is the easiest course. Okay, so please try to put the effort. Okay, try to write meaningful things. Okay, don't just write like few random miles and like 10 or 15 lines of code. This will show that you didn't even try. Okay, the solution should be at least 80% correct. At least the idea is correct. Maybe there is an index wrong here, index wrong there. That's fine. Okay, I am not expecting a fully working optimal solution from everyone. Now, most of you, they will reach this point, but it's okay. Okay, all what I care about is to see this guy, this girl made an effort. Okay, that's fine. They will pass. And please don't care about the actual mark itself. It's totally like something no one will ask you about in your entire life. Okay, so they are all estimation. I will estimate like you deserve 80, you deserve 90. Okay, we don't have like an actual answer that I will just compare it with your answer. Okay, all our assignments or our exams are just estimations. Okay, so those are the questions for the assignment. Okay, take all the time you need. Now, if you found that, oh, in 2 days or in 1 day, I was able to make it work and I have version number 1, try to make it better. Okay, try to optimize it, try to add more functionalities. Like, do you remember the Chinese guy, Dolphin, I told you about? Like, that guy was a machine. Like, he created a fully working, like a crazy, like hundreds of lines of code. And it had this, I know, I wasn't able to know what all the features in that thing. But that's how he thought. Like he never accepted to do only the requirements of the what we want. Okay, of course I can't ask the same thing from everyone. That's why I have like a minimum set of requirements. But you can do better. You can make this like a simple, like real life shop, dealing with customers, returning money. He created like a set of products. Like select the product you want to buy. You can buy, and how much money do you have? So it was a crazy solution. Okay, So I will send it to you. If you have any question now or during the week or during the weekend, uh, feel free to send me anytime. But I will try to reply as soon as possible. But try to not be blocked. Like try to do something else while I'm trying to answer you. Okay. Tomorrow in the morning we will have an exam. Okay. The exam is just intended to make you practice. It's not very easy. That's why it doesn't make you fail or pass. Okay. But it's just like to see yourself. Okay. To see if you are stressed out into a situation where you have like a hard task, what should you do or what you're going to do. Okay. And most of you will be able to do it, but it's like, please don't come and say like it's very hard, I couldn't finish. Even the best students in the previous group, most of them, they weren't able to finish everything. They finished most of it, but not all of it. And they were upset. Like some people don't accept to hand over something that's not totally correct. Okay. So I had to explain them that this is the whole point. Okay. That just to test something like this. We will have the test in the morning. Okay. So please be on time in the morning. And I will give you the whole day to finish the test. Okay. In the middle of the day, I need to leave to a doctor appointment, but hopefully I can still answer your questions. Okay. So I didn't want to take it a day off. I thought maybe you can start the exam and then I rescheduled to have it in another time. Okay. But you can start working on this right away. Okay. I will share the file with you and I will also send the code.
Mohammed, I have a question.
Yeah, sure.
For submission, we have to submit CS file or a source folder.
Yeah, so what we do is different actually for each project. Thanks for asking, actually. Let me show you how to do it exactly. Okay, let's share the screen. So you wrote the code here, okay? This is your code. This is your solution, okay? You need to find Solution Explorer. It's usually here. But if it's not there, from View, go to Solution Explorer, okay? This is what you have in the right. Okay, what I care about for this course, only for this course, is this program.cs. Okay, like write everything in the same file. Okay, don't create another file. And send only this file to me, program.cs. Okay, if you want to, like you can copy paste it to a new file, but you can also access it. So right click, right click on the project itself. There's something called open folder in File Explorer, or in Mac, what do they call it? What do they call the File Explorer in Mac? I just forgot. Okay, so open it and you will see it here and send me this
Finder.
one. Oh, Finder, yeah. Okay, so send this one. Okay, don't send those, especially exe files and stuff. Okay. In a later project, you will send everything. But for this project, just send the program.cs.
Okay, thank you.
Yeah, you're welcome.
In our case, we are going to send 2 files, right? One by one question, by each question.
Well, you can write both questions. It's functions. Okay, you can write them both in the program.cs.
Okay.
Okay, like you don't need to create a new one. And okay, but like every time there's someone who sends me this file, which is like nothing, or this file, or nothing, like an empty zip file. Okay, so
where do we send?
And of course, if you are uploading it to the system and it's not accepting, make sure you put it in a zip file. So right click on it. If you have WinRAR, then it will show up here. If you don't have WinRAR, which I strongly recommend to install, you can choose send to compressed folder or compressed file and send me that compressed thing. Okay, so this one is a compressed file that accepts, that has this inside. But some websites, some systems, they don't accept this, this extension, CS. Okay, they don't know it. Anyone was asking?
Yeah, I have another question. So Any requirement for the name of the variables or something like that, or
Well, like the more readable, the more clean the code, the higher the grade is. Of course, like it should be readable, it should make sense, but name them whatever you want, as long as it makes sense.
The file name, like, do we write our name or just?
Sorry, I thought you are speaking about the names inside. Well, if you can name it by your name, that will make it easier for us to grade. Like if you can name it like Willy first course assignment. Okay, that will, because we download everything and then we go through. Okay, so try to make it like meaningful. That would be appreciated. Okay, now for example, in a previous group, we asked them to send their resumes to us. So some of their resumes were titled like the name of the file, new file, or new Word document. Like imagine sending your resume, like it's you, like it's what represents you, and the name was unknown name or new Word document. Like how can I send this to a company? Okay, so that's a good point that you asked about this. Any other questions?
I have
Now,
2 questions. Sorry.
Yeah, I will let you ask just before I don't forget. I will try to set up the LMS so you can upload it to the LMS. If that didn't work, because there's always problems, if that didn't work because it's our first course, I will tell you to send it to Slack in a private message. Okay, so don't worry about sending. Yeah, sorry.
I forgot. Okay, so our deadline for this assignment is,
Well, it should be till Monday, but I will give you till Tuesday. Okay, but it
till
definitely
Tuesday
doesn't.
morning.
Yeah, Tuesday morning. Yeah.
So by Monday.
Whenever we say like Tuesday or Wednesday, it's before the start of the class. Okay, so Tuesday 8:45 or 9.
Okay.
Okay.
And one more question. If I wrote that, I think it's working. I want to optimize it. I did optimize as far as I could think. And could I get you to just take a look at it and maybe give me more hints on more optimization or something like that, or no?
Well, let's keep that after we deliver. So after we deliver, you can show me, and it's mostly
After deliver as in submission.
Yeah, after delivering and submitting your solution. Like
Okay.
it's not good to discuss solutions while we are still in the submission time. So after we submit everyone,
Oh,
we can
okay,
discuss
okay.
solutions. Maybe I will ask Zach to like explore some of the solutions with everyone.
Okay.
If you have questions, okay. If we have time in class, we can do it as well.
Okay. So solution and optimization would be after the deadline, when after submission. Okay.
Discussing them, but write the solution, write the optimization, then submit them.
Yeah.
Yeah. I mean the discussion itself, like is this correct? Is it? Let's leave it after we submit.
Okay. Thank you.
Yeah, you're welcome. And of course, like you always, like even after the finish of the class of the lab, you always have Zach. Like you can ask him, like, can I have half an hour of your time at the end of the day? Okay, if you have anything extra, if you have an idea to discuss, okay, because not all the time we have time in class. Okay, so don't delay it. Yeah, just do it right away. Okay, that's for submitting. And please make sure to like examine what you're submitting, so you don't end up submitting something that's totally different or not what we want.
Sorry, the way for submitting, we need to send you by email or?
Well, I will set up the LMS so you can upload it there.
Okay.
Okay, but sometimes since it's the first course, there are some technical issues. If that didn't work, send it to Slack. Okay, I will find it somewhere, like eventually. Okay. But this is a very simple, like it's one file, so it can be sent. Tomorrow we will do full websites. We can't just send. So maybe we need to upload them to GitHub or send the whole project. But this is a very simple one.
Oh,
Okay,
sorry. I just thought of one more question.
sure.
The ITLMS, the part where we submit in, I went in there, I logged on there a few days ago, and my courses weren't enrolled. Do I have to enroll it myself
No,
or?
no, I enroll you.
Oh, okay.
I will take all the
Okay.
names. I will take all the names from John, and I will enroll you course by course.
Got it. Okay, thank
Okay.
you.
Yeah. You're welcome. Okay. Any other questions?
Just a clarification. Tomorrow's test will be 2 hours or the whole day?
Well, it will be the whole day, but once you finish, you can finish. Like
Okay.
you can leave. Okay.
Thank you. Yeah, thank you.
But you have like I will set an hour for submission. Like you need to submit before this hour. But if you finish before, that's it. We always try to make Friday a little bit of a short day, you know. And if there's an exam, you really don't want that to be a very long day, right? It's stressful enough. Okay. Any other?
So we this weekend we have to our barbecue to postpone. Yeah.
Sorry.
We want to go to barbecue this in the park, so we have to postpone it to last.
Oh yeah.
Weekend. Yeah.
See.
Oh well, Jen and Millie couldn't make it this weekend anyway, so it's good that we are postponing. The food is very frozen right now.
Instead of going to the park, maybe we can have another exam, just to. Right. It's the same fun, right? Okay, so another exam on Saturday, guys, like this one.
Please be joking, right? Okay.
Yeah.
I'm very serious person. I can't distinguish between jokes and the real thing.
That's the bad thing. If we didn't have the assignment, yes, but we do have the assignment for you to work on the weekend. So
okay.
Unfortunately, yeah, we'll try to do it some other weekend.
Yeah.
Okay. Okay, so you can take 15 minutes break now before the lab. Okay, and please, like, just relax before tomorrow. Okay, so there's nothing to prepare if you are already working on the classes. Okay, just sleep and wake up, just relaxed and ready. Okay, there's nothing to study. Okay, yeah. See you tomorrow, guys. Bye.
Bye.